Hey everyone, it's Justin again. In the last video, we practiced with a few examples of word problems involving systems of equations, but there was one problem. They all had easy solutions. In the real world, there often aren't easy solutions, and in this video, we'll explore why. First, let's review the typical process to solve a scenario involving a system. First, identify information given to you in the problem. Then, figure out what information is missing and define those as your variables. Next up, use the known information and variables to set up multiple equations as a system. Then, solve the system using any of the three methods that we've learned so far. And finally, use the solution you found to answer the question. Let's try an example. You sell the berries from your garden every fall. One day you sell 12 packs of strawberries and 16 packs of blueberries and make $72. The next day, your friend stops by and purchases 3 packs of strawberries and 4 packs of blueberries for $18. How much does a pack of strawberries cost? So what information do we know? We know that 12 packs of strawberries and 16 packs of blueberries is $72. And we know that 3 packs of strawberries and 4 packs of blueberries are $18. But what don't we know yet? We know how much combinations of strawberries and blueberries cost, but we don't know how much a single pack costs. Writing our equations is fairly easy this time. They come straight from the scenario. To describe profits from the first day, 12 times the cost of strawberries plus 16 times the cost of blueberries equals $72. The second equation, representing your friend's purchase, is 3 times the cost of strawberries plus 4 times the cost of blueberries equaling 18. Now that we've got a system, we can solve. Using which method? Because the equations are in the same form with all the terms lined up nicely, let's use the elimination method. First, what should we multiply to ensure that one of the variables eliminates? We can multiply the bottom equation by -4, and now we have a new system where elimination is guaranteed. Now we combine the two equations together and... Okay, we got an always true statement, so apparently there are infinite solutions. But what does that mean when we're talking about the selling price of berries? If we graph, it might help. Well, there's the problem. Our two equations are actually the same line twice. There's no intersection to give us a definite solution. Instead, every point on this line is a possible solution. This point at 1, 3.75 tells us that it's possible that strawberries are $1 and blueberries are $3.75. This point at 2.3 tells us that maybe strawberries are $2 and blueberries are $3. Or this point at 4.6, 1.05 indicates that maybe strawberries are $4.60 and blueberries are $1.05. Without a definite intersection point, we have no way to know for sure what the prices are. This is what infinite solutions means. The system is made up of multiple versions of the same line with no intersection. Any point on the line is a solution with a possible answer. But there's no way to pick out the right one. Since the problem is that there was only enough information to write one line, not 2 different lines, we say that there is not enough information to solve the system. So then how would we answer the question? That's easy. We just say there's not enough information to answer the question. Next up, a pool equipment salesman is trying to sell you a new pump. He tells you his pump can drain 3 times the amount your current pump can in a minute. He then demonstrates the pump side by side, and his pump is 8 gallons short of tripling the amount your pump drained. How quickly does the salesman's pump drain water? What information do we know? We know the salesman's claim that his pump is 3 times better, and we know that his demonstration fell flat of that claim by 8 gallons. What don't we know? We don't know the actual strength of each pump, so let's set up our equations. The salesman claimed that his pump drains 3 times as fast as yours. During the demonstration, his pump drained 8 gallons less than 3 times the amount yours did. Let's solve this system. Which method do you think we should use? Because at least one of the equations has an isolated variable, let's use the substitution method. Take the second equation and substitute 3x for y, then solve. Subtract 3x from both sides, and we get a false statement. Remember, that means there's no solution, but why? Let's graph the system and see. Oh, that's why our system created two parallel lines. These lines will never intersect, so there's never going to be a solution. That's what no solution means in a real-world scenario. This system created parallel lines, and those lines will never cross, so there's no solution. This tends to occur when a hypothetical situation is impossible. So back to the problem. If the system has no solution, how can we find out how quickly the salesman's pump drains water? We can't, because this situation is impossible. It's pretty obvious to see why, too. The demonstration proved the salesman's claim was a lie. Even problems without an easy answer have clear reasons why. A scenario with infinite solutions hasn't given you enough information to write two different equations, and a scenario with no solution contains conflicting information that makes the scenario impossible. In the next video, we're going to finish up this unit by using systems to solve logic problems. And yes, some of them will not have enough information, while others will be downright impossible. And it'll be your job to be able to tell the difference. See you then.